On a clear night, when staring up at the night sky, it's hard to picture the scope behind the shining dots above you. It's hard to fathom that these lights hold the key to understanding the history of our beings, and that each dot tells its own story of time, as well as, space. But what if we could? What if a picture could paint 1,000 worlds? I'm Christine Brunner, and this is Siemens Short Stories. On the outskirts of our solar system sits our sun's closest neighbor, the red dwarf Proxima Centauri. It's due to this closeness that it has become one of our best studied stars and given us a wide host of information. For instance, it's a lot smaller than our own life-sustaining ball of gas, sitting at only 12% of our sun's mass, and has an orbit of only 81 days. And yet, despite its relatively diminutive form, it still has activity levels and X-ray luminosity comparable to our sun's. However, despite all this insight, shockwaves still rippled through astronomical society in 2016, when clear evidence was presented in the scientific journal Nature that our closest star neighbor had its very own orbiting planet. What's more, this exoplanet had temperatures that allowed for water to be liquid on its surface. In other words, exoplanet Proxima b might be in a Goldilocks zone, and the first planet other than our own that may be capable of sustaining life. That's kind of cool, isn't it? Up until now, the existence of Proxima b has been lost to us, as it was too far away from the Earth to be seen directly from space or Earth-based telescopes. It was only found thanks to precise calculations. But what else are we missing because it's just outside our reach? These are the challenges that the next generation successor to the Hubble Space Telescope, the James Webb Space Telescope, hopes to address. For this dream to become a reality, software is key. Mentor and Siemens have been instrumental in helping bring the telescope to life. The integrated science instrument module in the telescope contains a complex mix of sensors, cameras, and electronics. And it was thanks to the extensive use of Mentor's software that each of these elements work as one. Mentor's Tenor design suite was used to create the all-important analog to digital converter array. This is what allows the photos taken by the James Webb camera to be turned into digital images, which can be downloaded to Earth. They were even able to create a stable enough system so that the telescope can run on limited power and resources for its 10-year journey. Not such a small feat, seeing as it will be somewhat difficult to service the telescope when it is 1,000,000 miles away. It is thanks to these innovations that the telescope will be able to peer substantially further through the dark matter clouds of the universe, right back to the Big Bang, to the first light, and to the birth of our stars, supporting the search for life on planets outside our solar system, just like our new little friend Proxima b. Siemens Short Stories is a production of Siemens. If you would like to read more about our involvement in the James Webb Space Telescope, don't miss to download the white paper at mentor.com. Tune in again in 2 weeks for more small stories on big innovation.